Welcome back everyone. Part 3 here in our single-ended tube amplifier build. I can tell you I've gotten an enormous amount of response to this video series. People are pretty excited about it, so it's got me excited about it. I want to apologize. I've been a little slow on the videos, especially this one and the series back on the analog discovery device. I had some problems in the basement recently and had to evacuate part of it due to some water. And we've just been a big mess for 2 weeks in a row now. So finally getting back around to some of this. Let's dive on in. I will tell you, this might turn out to be a really long video, or if it gets too long, I may break it up into 2 parts. But what we're going to dive into today is the components, i.e. the build of materials. And you can see I've got a few laid out here on the bench. May or may not be the ones we end up using in the end of this thing, but kind of give you an idea where we're going to head today. In the series, if you'll remember, we made it through the overall architecture of the tube types, kind of the design and the schematic, and now we're down to, okay, what are the individual components? In other words, what's the parts list that we need to go and acquire, and otherwise known as the build of materials or the BOM. And then we'll kind of go on from that. We'll build it on the bench, be our test build, kind of tweak it, modify it, put it, kind of figure out how we're going to lay it out, put it in a chassis, actually go build it, and then test tweak a little more and finalize the build at that point. Okay, the goal here, just so everyone's clear, isn't to build the world's best tube amplifier. Although I'm planning to build a good one. This whole video series was designed to build something fun, something educational, something that had a little bit of nostalgia around these 807 tubes, and something fairly simple that people could get their heads around. I have gotten a significant amount of comments on my YouTube thread, Facebook, and other emails basically saying, hey, I think you need to change this about the design. Why not make it look this way? Why not turn it into a set of mono blocks? Wouldn't it be better if you did this, that, and the other? And I even had one person, by the time they got done telling me all the things I should change about it, I basically responded back and said, hey, you might want to consider making a video of the amplifier you're planning to build, because it's nothing even close to the amplifier I plan to build. So like I said, I kind of stumbled across this triode DIC design at one point. I've been wanting to build a 807 single-ended amplifier for a while. And I also found some threads out on Audio Karma that were pretty insightful, and just kind of inspired me to dive into this and make this video series. So whether you like what I'm building or not, it's what I'm building, and we'll see how it goes. I said here, let's try to keep the spirit of the design, and I'll say the spirit of the design, as close to the triode DIC's design as possible. And you'll see more why I'm stating that statement today. It's not always possible to find a schematic online, and let me say that again. It's not always practical to find a schematic online and build it just like the schematic online, and you'll see why here in today's video. And then again, remember, a lot of this is subjective. I'll say we need to use this component, and somebody else say, yeah, but I've used another version of that component and it's better. And hey, well, we all think something's better or worse. Kind of like, my favorite color is orange, and somebody else would say, well, it's a horrible color. So it's all subjective. Okay, I'm going to ask a favor of my faithful viewers out there, and that is to heed this warning. Please, if you plan to build this, please don't buy parts yet. I've had a lot of people email me and say, hey, I want to build this thing along with you, and I want to go ahead and get the build of materials so that I can order parts, so I can be building this at the same time you are. Well, I'm going to ask you to wait until I have gone through the whole video series, worked out all the kinks and design considerations, and then when it's finalized and sounding good, I'll post the build of materials, I'll post all the schematics, then you can order your parts and come back and watch the video series again and actually build it. And let me tell you why. I'll give you an example. Let's say you looked at the schematic and there's a 120 ohm resistor in it, and you ordered those as part of your order. Well, they all show up, and then in my next video, I decide, you know what, I don't really like the 100 ohm. I'm going to change that to 120 ohm to bias this thing a little differently. So all of a sudden you hear that and you go, oh gosh. So you jump online to Mauser or wherever and you buy the 120 ohm resistors. And then, oh gosh, by the way, they charge you about $7 shipping for those. So you got $10 or $12 in these parts. And then the next video I make, I say, you know what? I decided I really like the 100 ohm better. So I've switched back to them. And there you are stuck with $12 worth of parts that you may or may not ever use again. I'm lucky enough to have a pretty vast parts inventory that I've built up over the years, so I can swap stuff in and out, and it's no big deal. You, on the other hand, you could have a lot wrapped up in parts. The same as I may decide to change the choke along the way from a 10 Henry to an 8 Henry. Well, you know what? There's two of those in there, and they're about 25 or 30 bucks a piece. I'd much rather me work out all that than you. So due to this, I'm going to wait till we get done building this entire series to post the builder materials. I'll also post the schematics on my website, and then you could go about building this thing. Thanks for listening to this, everyone. Okay, back to those words I used called sticking to the spirit of the original design. Well, I've got a tweak or two along the way that I'm wanting to make because it's a little more practical maybe, or it's just a belief system that I have. One of those is they have this switch here that's ultimately designed to let the heaters warm up in this amplifier before you flip this switch and actually apply the B plus to the tubes, to the plates of the tubes. And there's kind of a reason I don't like this scenario right here. One, it's two extra components. It's a switch and a resistor. Two, this thing is using a tube rectifier, and they warm up slowly anyway. So it's not like the B plus is all there right out of the gate the second you hit the power switch anyway. And second off, you can achieve a similar effect by putting a CL, either CL80 or CL70 thermistor on one of the 120 volt input legs in series. So in other words, where your power cord comes into the unit before it jumps onto either the fuse holder or the switch or whatever, put a CL70 thermistor in line. It'll cause just a little bit of voltage drop, which is not bad for 120 volt connections these days. And two, it will also cause a little bit of slower startup. So this is just one I'm recommending we take that out and simplify the design all the way around. So that's what I'm talking about when I say design considerations. If you had already ordered all your parts, you'd have a switch and a spare resistor you wouldn't need at this point. This is the original transformer here, a power transformer as specified in the original triode DIC design. And I want to talk about it for a minute as a kind of a point of reference. And you'll understand why here in a few more minutes. But if you'll notice, this transformer has 6 sets of windings. You've got your 120 volt primary winding over here. Then you have your high voltage winding here, 380 volts times 2 with center tap in the middle for your B plus. And then you have 4 different sets of windings for your filament voltages. In other words, 6.3 volts right here with a center tap at 4 amps, 6.3 volts here with a center tap at 2 amps, 6.3 volts here with a center tap at 2 amps. And if you'll notice, this center tap is brought over here to this point because normally that would be sitting at 0 volts DC. And what they're doing is they're pulling off of this point right here, which basically has about 450 volts of DC sitting right here. It's before the choke. And what they're doing is they're basically using a voltage divider between these two resistors, between this 390K and this 82K. So if you think about it, they're basically suspending the 6.3 volts up. If I did the math, I'm guessing that's around 70 or 80 volts right there. I'd have to actually do the voltage divider math, but they're suspending that AC signal on top of a 70 or 80 volt DC offset. You could think of it that way. And then this little filter cap here just helps smooth that a little bit. But really what they're doing is, kind of floating this 6.3 volts up off of ground, off of 0 volts. And that's very much needed for this RPP stage right here. It helps with noise rejection. kind of gets off the noise floor, etc. And but my point is, it would not hurt if you did that on all of the 6.3 volt windings here. And then also you notice you've got this 5 volt winding here, which feeds the filament of the 5R4 or 5U4. And the center tap on it is switched here to keep B plus from being turned on or off. And that, like I said, we're going to eliminate that. But pay attention to all these different windings and the fact that a lot of these are center tapped windings at this point. And if you'll notice, if you'll add up just the 6.3 volts here, 4 amps, 2 amps, 2 amps, that's 8 amps worth of 6.3 volt windings right here. And you've got a 5 volt at 3 amp winding right here. So pay attention to all that. You'll see why here shortly. Back to the handy dandy 807 data sheet. I want you to look at something here. Remember the heater, and I'll tell you right here, 6.3 volts, and it doesn't care whether it's AC or DC, and it pulls 9 amps of current, so 0.9 amps per 807 tube, okay? Okay, and this is a 6SN7 data sheet. If you'll notice a 6SN7, whether it's the GTB or GTA model, 6.3 volts heater, AC or DC, and each tube consumes 0.6 amps of current, okay? And then onward to the 5U4 rectifier data sheet. If you'll notice here, filament voltage, AC or DC, 5 volts, filament current, 3 amps this thing wants to feed it. Okay, back to the original circuit now. If you'll count, we're gonna have one 807 per channel, so 2 of those total. And then we're gonna have one, remember this is one 6SN7 right here. Remember it's a dual triode. There's 2 triodes in each glass. So I'm gonna have one of these per channel, and I'm gonna have a half of one of these per channel. So it is possible, and I'm probably going to do this. You can use one 6SN7 right here to do both front ends, this section right here, for both the left and right channel. In other words, you can share this tube between the left and the right channel. So in other words, I would need one of these for the right channel, one of these for the left channel, and one of these that I'm going to share between the two. In other words, 3 total in this amplifier, 6SN7 tubes. So based on that, if you'll notice here, 2 807s, 6.3 volts at 0.9 amps each. 3 6SN7s at 0.6 amps each. So that gives you 1.8 amps plus 1.2 amps. So to feed all of the 6.3 volt tubes in this unit, I would need a minimum of 3 amps. That's exactly what the math comes out to. But I'd probably buy something that could handle 4 or 5 amps. And then I need one 5U4 that can handle 5 volts at 3 amps. And you could either buy a 3 amp or a 4 amp. I tell you, a lot of times 3 amps is all you need on a 5U4. You don't need to build in a lot of extra overhead on that one, just from experience. Okay, so this is a what I would call an application data sheet. And I found this out on duncanamps.com. And what it'll tell you is for a Class A, which is what we're building, single-ended amplifier, if you're putting around 500 volts on the plate, in other words, volts on the anode, the plate and the anode is the same thing, you should see around 50 milliamps of current, in other words, IA, current through the plate, 50 milliamps of current. Now, if you remember, this one was putting around 450 volts on the plate. So because that number is lower here, this number may go up slightly. You may see more like 55, 60 milliamps going through this thing at the end of the day. So that's the total kind of, current that each of these power output tubes is going to pull, somewhere around the 50, maybe 55 milliamps. And so based on that, your B plus, i.e. power supply current needs, I was around 50 milliamps. So let's just be super generous, because we've also got to take into account the current that these 6S and 7s will pull. Let's just double it to 100 milliamps per channel that we're going to need from the B plus power supply. So what that tells me, at the end of the day, I'm going to need 2 chokes inside this thing at 10 henries at 100 milliamps each. And my power transformer could be at 200 milliamps on the B plus. If you'll remember back to the original design, they had a 380 volt, 300 milliamp transformer in it, which was a little bit of overkill. They could have gotten by with a 200 milliamp. And if you'll notice in the original schematic, it told you a 10 Henry choke here and a 10 Henry choke here, but it never told you what current rating on that choke to actually deploy. So now you know that answer, and you saw how we figured it up by figuring out the plate current this thing's going to pull and adding a little bit to it. So you need 2 chokes, 10 Henry, 100 milliamp, and 1 power transformer that'll do at least 200 milliamps on the B plus. And you're probably wondering, why am I telling you all this stuff when you've already shown me what to build in the schematic? Well, remember earlier I talked about it's not always practical to build exactly what the designer says. And so here's a good example of why. So first off, I sent an email to Dick and said, hey, would you mind telling me where you got your transformers from? I'll just order them from the same place. That way I'll know I'm building the same thing you built. And he was kind enough to respond back, told me where he got them, and he got them from a company called Automatic Electric in Europe, or Automatic Electric Europe. I emailed them, and this is what they emailed me back. Good morning, Mr. Mark. They would sell me an 807 single-ended EI core transformer, 2 chokes, 2 output transformers, 1 power transformers for €350. And they also said it would cost me €220 in shipping in 2 different packages. Takes 6 weeks to get it. Payment is in advance. Kind regards, AEE. But ultimately, I kept emailing back and forth with them, and it made it very well likely is a English to whatever language they were in. I'm not sure if it was Dutch or French, but I never could get some answers out of them I was looking for. First off, I wanted them to send me a spec sheet on these transformers. I could never get them to do that, and maybe it's just a language thing. But the thing that ultimately kept me from ordering this was 2 things. One, they never could respond whether they could make the primary 120 volts. I didn't want to order this and it show up and then be set up for 220 or 240 volts European on the primary, and I'd have to worry about a step-up transformer or something else outside the amplifier. So because I could never get an answer to that, and if you do the math on €350 plus €220 shipping, it's $624 for the transformers for this thing. I thought, wow, maybe I can find something similar here in the US and make this thing work without that expense and without taking the risk of wondering whether I was going to get something with a 220 or 240 volt primary. So ultimately, that is why I did not go down this path. Ultimately, why I explained all those things I just explained to you a minute ago, because you're going to need to know those things when you go to select your transformers here in the US. Or if you're in the Europe watching this, order these things and build it just the way Dick did, and it probably won't cost you $220 in shipping. So what I'm going to walk you through are some various power transformer options that you have in building this amplifier. Some of these, it was cool because I found them in one of the Audio Karma posts that had been going on recently about this Dick amplifier. This one probably would not have hit my radar if I had not seen that thread, but it's a Hammond transformer, part number 6K7VG. It is $53 plus shipping. If you notice here, primary 110 to 120, 50 to 60 hertz, 750 volt center tap, which is good, at 150 DC milliamps, 5 volts at 3 amps, 6.3 amps at 5 amps. So in other words, this 150 milliamps right here, if you remember earlier, I said, we might want 200 milliamps. But honestly, you could probably get by with the 150 because each of those channels is probably going to pull 50 to 55 milliamps. Each of these, the 6SN7s are going to pull just a few milliamps each. So you're probably at the most sitting around 60 to 65 milliamps per channel. So in that case, 150 milliamp transformer would probably work just fine in this amplifier with no issues. And you've got enough, if you'll notice here, back to our 5 volts at 3 amps, which is what we said here, 5 volts at 3 amps. And you've also got 6.3 amps at 6.3 volts. Oops, I need to change that. At 5 amps. And if you'll notice, we had 6.3 volts at 3 amps. So, hey, that transformer would probably work. You're running it close, pretty close to its tolerances. But I think it would, honestly, I think it would end up being fine. If you'll notice this one here, 380 and 380 is 760, whereas here you would have 750 volts. Trust me, it's not going to make a difference. You can adjust that out easily. This thing will operate fine with 750 volt center tap. So by far, this is the least expensive path you can take at $53. Up next, Edcore makes a transformer, the XPWR198. It's $94. This thing is a hoss. It is pretty big, stands up really tall, got a pretty good bit of weight to it. But if you'll notice, it's the same thing, 750 volts, but this one's at 300 milliamps, so twice the current as that previous transformer I showed you. It's also got a bias tap here, which we would not use. You could just tape those or heat shrink off those windings. You wouldn't need them. And then you got 6.3 volts at 6 amps and 5 volts at 6 amps. So this one's a little bit overkill, but it would do the job and run nice and cool. I can promise you that much. And last but not least, this one I found via that forum post as well, and it might be my favorite. So it is made by Classic Tone by Magnetic Components. This one's only 710 volts though. So this thing's going to run a little cooler. In other words, instead of this thing putting out maybe, maybe 8 watts, maybe it's going to be a 7 watt or 7.5 watt amplifier. But I don't think it's going to matter, honestly. I think this thing will bias out perfectly, and I think it would sound great. And the life of the components run a little cooler or whatnot. It's got another tap here at 610 volts. We wouldn't need that, but this, and a 50 volt bias tap, wouldn't need that. But this is 710 at 220 milliamps. This thing would work great. You've also got your 6.3 volts here at 5 amps and your 5 volts at 3 amps here. And this thing's $92. But what I really like about it is this is kind of a top-down mount. I think they call it a flat chassis mount or something along those lines. And if you remember the old Dynaco 70 look, you had these two transformers here kind of stood up, and then you had this other transformer here kind of laid down. Well, not only is it very kind of cosmetically, aesthetically appealing to me, there's also a scientific reason I like this one a lot more. And that is because this transformer is laid flat. If you notice, the windings are in this plane, a horizontal plane, whereas these windings are kind of in a vertical plane here. And so you don't have to worry about turning your transformers different directions to keep them from interacting with each other when you have this one laid down flat. So this one's actually my favorite, although it's harder to do because you have to cut a bigger hole in the chassis for the bottom part of this thing to drop through. This might be the one I go with as we build this thing. Okay, I'm going to quiz you a little bit. So if you'll notice here, what is different about these three transformers that I just showed you and the original design? Couple things. First and foremost, let's see if you can figure it out on your own. Pause the video and just go back and forth and study it a little bit and see if you can figure it out, and then come back and hit start again. All right, here's what the differences are. One, you've only got one 6.3 volt winding here at 5 amps, right? If you go back to the original schematic here, you've got 1, 2, 3 6.3 volt windings. But this is going to work out, I'm promising you. Well, this one also has, if you'll notice here, a single 5 volt winding right here. This one has a single 5 volt winding, and this one has a single 5 volt winding at 3 amps. If you go back to the original, this one had 3 amp 5 volt winding, but did you notice? This has a center tap. None of these. This 5 volt winding here, this 5 volt winding here, and this 5 volt winding here, none of them have center taps. The 6.3s did, but the 5 volts don't. It's very common to see 5 volt taps without a center tap in, or 5 volt windings without a center tap in them. So I've modified the triodic schematic at this point in time to basically take account for that. If you'll notice, I've got one 6.3 volt center tap at either 4 or 5 amp transformer. In other words, I'm going to put it here and connect all of my filaments via these two connections. And I'm going to float this thing up using this little voltage divider here for all the tubes with some DC offset. If you'll notice, I also modified the schematic. I've gotten rid of the center tap here. I've gotten rid of the switch and the resistor that was there. And I've tagged off of one of the cathodes here, this tube, to feed over here where you're actually going to feed your 450 volts. So if you want to use one of these US made transformers that doesn't have a center tap on the 5 volt winding and doesn't have 3 different 6 volt taps, this is what it's going to look like at the end of the day. It's pretty simple. It's actually a simpler schematic. So like I said, because the design considerations and it not being practical for me to order the transformers that Triodic used, got to make some slight modifications to these things. I'll end up posting this on my website as well. But I hope you're following along at this point on what I've had to do here to try to use a slightly different transformer in this scenario. Okay, so let's jump on over now. We've covered a couple different power supply options for you, or power transformer options. Let's take a look at the output transformer options. So this is a company called Transcender. This is a TT-312-OT transformer. They're $80 a piece times 2. You'd need 2 of these at a total of $160 for your amplifier. This thing has 5K with a full 40% ultralinear tap into 8 ohms, 20 hertz to 90 kilohertz, pretty good ratings here. It'll tell you this thing will handle up to 90 milliamps. Well, remember, we said we're only going to be running about 50 to 55, maybe 60 at the most through this thing. Even on peaks, I doubt we would hit 90. It tells you the DC primary resistance of the windings in this thing and the primary inductance. But you kind of get the gist here. Nice little stout transformers. And I actually own a pair of these. I'll show them to you later, probably in the next video. But the downside, this would be my favorite choice. If I was going to tell you the best value for the money, these are some amazing quality transformers at not a huge price point. Sadly enough, Transcender has stopped taking orders. Their website's still up. But when you go to order on there, the web page is kind of blanked out. And I emailed them and asked them, and they said they probably wouldn't be taking any orders anytime in the next year. So I don't know the story behind that. So it could be closed up, and maybe maybe they'll come back one day. I didn't get a lot of clarity on that. But so anyway, I just happen to have these from another project laying around here. So I'm going to probably play with these, but we may or may not use them. We'll see what sounds good. All right, and a similar size transformer. This is a 15 watt transformer, 100 milliamps, so slightly other. Remember the other one there, that was that's a 10 watt transformer. And this is a 15 watt transformer. 5K ohms, 40% screen tap. 40 to 18 kilohertz, and pretty good noise figures on this thing. Hey, these are only $42 a piece times 2, $84 from Edcore. So because the Transcenders are no longer available, I went ahead and ordered a set of these as well. Got them back here on the bench. and I think they would work great in this amp. So you'll get to see those as well. And because what I didn't want to do is I didn't want to build this amp with parts that you guys couldn't go out and obtain. So even though I may try it with those transcender transformers, I'm also going to try it out with these Ed cores. Just this would be a good all-around budget transformer. Wouldn't break the bank and probably sound great, to be honest. And up next here we've got the 1628 SEA transformer from Hammond. This is a stout one too. These will handle up to 30 watts. So the cool thing about this, if you ever wanted to buy these, this 5K tap right here, or secondary impedance, it can be used with a lot of different kind of tubes. And so if you just want a good set of bench transformers, this would be a good set. Notice these will handle 120 milliamps each. Got the screen tap as well, and it's also got 4, 8, and 16 ohm taps. These are getting a little pricey though. $144 each times 2 is $288. So, but I tell you, if you bought this and that other Hammond, or the first one I showed you here, which was the Hammond transformer here, they would match up really well and look good. You just end up probably turning this one sideways in the amplifier so that your fields between all three of the transformers mounted at the back don't get in the way. And we'll talk more about that when we get into layout later. And up next, let's just hypothetically say I built this amplifier and it sounded really good. And then I got this crazy idea, you know what, I'm going to mass produce 20 or 50 of these amps and sell them on the market, right? This is where I would go. It's a company called Monolith Magnetics, makes some amazing transformers. They're overseas in Belgium. And they've got transformers that range from just a few $100s to thousands of dollars. These guys really know their stuff, and they're using some of the best quality materials and design techniques in the industry these days. These, Hashimoto, and a few other really good ones are on Tamara or whatnot. Really good transformers. But as you can notice here, these things are €309 a piece, which comes out to be $678 plus shipping. But I can promise you, if you want to build an amazing amplifier, this might be where you would go. And they also sell power transformers. Most of their power transformers are custom design, and they're about 200 and some euro each. So you'd basically give them the specs. They build you what you need. But thought I'd just give you couple different options there on transformers, unless somebody might already be in Europe and the shipping might not be bad. Hey, this may be a good route to go. These guys are pretty good. I think I'm going to go ahead and wrap up my video at this point because I'm already 30 some minutes into it, and yet I haven't even made it to the bill of materials yet. But I did want to go through a good bit of design considerations, and we'll even talk about more as we get into the bill of materials. So I'll make this bill of materials a multi-section section part. Hopefully you're learning something here, because this process I'm going through, I can't even count the hours I spend when I build something that I spend researching parts and posting on forums and reading on forums just about the pros and cons of different parts. It's all part of the fun for me in building an amplifier, is deciding what components you're going to use. It's like on this one, wow, could I get by with the 10 watt because it's going to handle 90 milliamps of current, or wow, should I bump this thing up to the 15 watt? You know, and I'll spend a lot of time trying to do research around things like that. So hang tight. We'll get to this build of materials very shortly. Hopefully this weekend I'll get both these videos up. Thanks for watching, everybody. Stay tuned. Part 4 coming soon.